pause. No. Yeah, no, it's recording again. Welcome back. This is the second lesson about differential equation, solving differential equation. We've dealt with the direct integration, the first method, and some equations cannot be solved by direct integration. We're going to use a method of separable variables. That is where the differential equation, when you look at it, you can actually separate the variables. We'll do a few examples and it will be clear then. What I need you to know now, because in this section we're going to use a lot of logarithms, I need you to go back and revise the rules of logarithmic, the rules of logarithms, mainly these three rules. I want you to spend some time on that because we're going to use it a lot from now on. And the other thing I would like to introduce to you, this integral where you see a fraction and the top of the fraction, the numerator, is equal to the derivative of the base, of the denominator. Then if that is the case, you can integrate it just by recognition. So in this case, you've got 2x divided by x squared plus 3 dx. So the solution of this one, of this integral, that's going to be equal to, y is going to be equal to log of the base x2 plus 3. That can only be positive, plus c. That is another example here. And the derivative of the bottom of the fraction is 3x squared. So what we need to do, we need to divide by 3, and the answer will be 1 over 3 log, natural log of the base, which is x cubed plus 1, and as usual plus c. This is one example of this equation, example 3. If you look at it clearly, if you look at it carefully, you can see that you've got some x and y on the same side. So really you cannot do this by direct integration. If that was 2x over 1 plus x over 1 plus x, you can do it by direct integration. You got dy dx, on the other side 2x 1 plus x dx. You can do that by direct integration, but as it is, you've got y on the right hand side and y on the left hand side. So what you should do, you should gather all the x terms to one side and all the y terms to the other side. In this case we just cross multiply, so we say 1 plus y cross multiply dy. We treat the dy and dx just like any other number, and then cross multiply the other side, 2x dx. Now we can take the integral of both sides, 1 plus y dy equal to the integral of 2x dx. Then we integrate as usual, so that's going to be integration of 1 is equal to y plus integration of y, which is y squared divided by 2. You could have a constant here, call it 1, equal to integration of 2x, which is 2x squared by 2, plus a constant, and that will be equal to y plus y squared over 2 equal to x squared plus, we can gather them two constant and call it c, and that is the general solution. Try this example now on your own. I'll pause the video for a minute and come back. Okay, that is the solution. What you do is you gather all the y terms on the left hand side, the x terms on the right hand side. You integrate both sides, y with respect to y and the x with respect to x, and then you get this answer plus c. Okay, here you have to use the logarithm rules, and then using some algebra you finish up with this, and that is the general solution, a being the constant. Okay, this is another example which is given on your bright space. That is the solution for it, and I will give you another example and solve it for you, and you should be able to solve all the questions on exercise 2 after that. That's another example, and we are given this equation. We need to rearrange it so that, let's first define all the variables that we will need. We know r is a constant and l is a constant, so that will not play a part in the integration or the differentiation. So we only got I, we got t, and we got I. We need all the i's in one direction and all the t in on the other side. So di, got a di over I equal to this constant multiplied by dt. If we integrate both sides, we get log of I equal to this. We get this relationship, and eventually we finish up with this. I is equal to a times e to the power constant times t. This a is just, we manipulated that using algebra, using logarithmic rules. So we got I equal to a e to the power r l t, and this is the general solution. In part B, we are supplied with more information and we need to find more specific solution. Okay, this is part B. We are given these conditions. We've got I is equal to 4 and t is equal to 0.8 millisecond, and the constant are given as well. So what we need to do, we substitute these values in the equation we have got from part A. We've found this relationship, I equal to a times e exponential to the power r over l times t. So we know I is given to be 4. A, we want to find this. We know e, and r is equal to this, and divide by l, which is given by 2. That will give us a value for a to be, a is equal to 19.812. Now we substitute this value back into the equation, and we need to find the time. Okay, when I is equal to 1, so I is equal to 1, we know all these values, we just need to find t. And you should get this answer. So we know all these values, r, l, we want to find t. Manipulate this equation to give us that, and then you should get a value of 1.49 millisecond. That will conclude the second part of differential equation. Now you can do exercise sheet 2.